everybody, my name is Josh. I was a computer science examiner for multiple exam boards, head of computer science for UK based schools, and now I run a tutoring business where I've helped thousands of students to get better grades in computer science related courses. Now, when I was going through the lesson yesterday about converting denary numbers into floating point numbers, I actually forgot to show you how to do it for negative numbers. So I just thought today's lesson we could have a little recap of positive numbers, but also we'll go through negative numbers and make sure that you're feeling super confident with those. So with this is just going to be a positive conversion. So essentially the idea being that you want to go for 0, 1 on these. 0, 1. That's what we want on the front. And if it was a negative number, it would be 1, 0. Now, with these, we're just going to start off and convert it into a fixed point binary number. And it wants it in 8 bits. So we're going to do 64, 32, just doing your things in there like this. 16, 8, 4, 2, 1 and 0.5. Now, the next stage is, so 64 isn't going to go, so I'm going to put 0 there. And then I'm just going to take the 32 away from that. I'd just maybe recommend with some of the slightly larger numbers that what you're going to do is when you're taking it away, it's going to maybe use column subtraction because that's where you're more likely to make a mistake. If in OCR and Cambridge International you don't have a calculator, AQA you do, so you're probably less likely to make a mistake if you're in AQA. But still, you know, it's worth checking, isn't it? Because, you know, there's a lot riding on these tests ultimately. So 32 there, and then we just need to make up the 13.5, which is a smaller number, so we're less likely to make a mistake, which is going to be the 8, the 4, and then the 1 there. And then we just need to put in the 0.5. Now, that's step 1. So step 1 is we get our fixed point binary number. The next stage of what we need to do is we need to work out what the exponent is going to be. Now the exponent, as I was saying to you, is that's all to do with where we need to get the decimal point in between the 0 and the 1 at the front. And how we do that is the decimal point is in between the 1 and the 0.5. Little mistake that I see quite a lot of students doing is what they'll do is they'll actually go back to the start here. So just be super, super careful that what you don't do is that you don't go for, you know, right at the back because people just think, oh, it's at the end. If you've got like quite a large decimal number, you know, if whatever that might be, just be really careful that you're putting the decimal point in the right place because either that's going to hugely change what the exponent is. So anyway, from there, we're just going to move the decimal point. So we're going to go 1, 2, 3, 4, 5, 6, and we're moving it in between here because it's a positive number. So we move that 6 times. Redraw your number. So decimal point here, and then you're going to go 1, 0, 1, 1, 0, 1, 1. Now we moved it 6 times, so that tells us that our exponent is going to be 6, so, and it needs to be 4 bits, so 0, 1, 1, 0. So that's the 4 and the 2 there in the exponent. Lovely, all done there. Now, negative numbers are ever so slightly different. Nothing crazy. There's a lot of the same steps. We just got to remember at some point we've got to 2's complement it. So step 1, exactly the same. Just convert that into a 8-bit binary number positive. So I'm just going to do positive to start with. No different than what we were doing before. And then we're going to go 0.5. So we've got put same numbers in there. And then what we do is we just put 0, 0, 0. Depending on how confident you are, as I said, if you want to take them away and do that stuff, that's no problems with that. So 14 is going to be 8, 4, 2, 0, and 1. Now, this is the different part. So what we need to do now is we need to 2's complement this because it's a negative number. So my little method, which is I go from the right to left, everything at it and before it stays the same is only that. So that's going to stay the same. Everything after it is flipped. So that becomes a 1, that becomes a 0, that becomes a 0, that becomes a 0, that becomes a 1, that becomes a 1, that becomes a 1. Okay. So that's step 2, which is different from the one that we've done before. Step 3 is the same as what we did on the other one, which is where we need to work out the exponent. So step 2 is now going into the position on that one. Okay, so look at the decimal point is in between here. Do not make the mistake of what some people do is they go back to the start here because they think, oh, it's the start. That's where the decimal point is. Now, you will not get marks there, people, so please be careful on that one. And then all you're going to do is you're just going to move it so that the number that we've got is going to be 1, 0. So we're actually going to go for this position here, okay? Now, so that's really, really important, because with negative numbers, when we 2's complement them, these are essentially going to turn back into zeros anyway, so that's why they're not relevant. Some people feel a little bit weird about getting rid of those ones there, but when we 2's complement them, they just turn back into zeros, so they're irrelevant. So we're actually going to go to this position here. So I guess that's probably the second place that I would see students get a little bit confused, is they would maybe think about putting it here. We don't put that there. For it to be fully normalized, it needs to go here. So what we're going to do is we're going to go 1, 2, 3, 4. Redraw our number, which is going to go 1, 0, 0, 0, 1. And then we need to have an 8-bit mantissa here, so we need to add in 3 zeros at the end. And we moved it 1, 2, 3, 4 times. So that is going to tell us that we need to have a mantissa, an exponent, which is going to be 4. So that is going to be 0, 1, 0, 0, which is the exponent is now 4, because obviously 1, 2, 4, and then we've got a mantissa which is like that. And that's how you convert a negative number into floating point.